Hello everyone, I'm Zachary Brewton and today I'll be talking to you about center of gravity and centroids for BCN 2405, Statics and Strength of Materials for the Construction Management program at the University of West Florida. First off, what is the center of gravity? The center of gravity or center of mass refers to masses or weights and can be thought of as a single point at which the weight can be held and be in balance in all directions. Every object has a center of gravity, which depends on the distribution of mass. For simple shapes, the center of gravity can be located geometrically. Example, center of a sphere or a rectangle. Think of a seesaw. The balance point where the object remains stable or in equilibrium is considered the center of gravity, so the center of the seesaw. What is a centroid? The centroid is a geometric center of a shape or object regardless of its material or weight distribution. So compared to the center of gravity, a centroid does not take in consideration the weight. The centroid is based solely on the shape's geometry and not its mass or gravity. So ignore the weight and use the object's volume. Because of varying densities, the center of gravity and the centroid do not coincide. Example. In the case of a hammer with a wooden handle, its center of gravity would be close to the heavy steel handle, and the centroid, which is found by ignoring the weight and considering only the volume, would be closer to the middle of the handle. Applications of center of gravity and centroids. In construction, centroids help design stable structures and ensuring even load distribution. So this is used for everything from buildings to bridges. So it is very important in the construction world. It can be used for almost any application we will use. Steps to solve centroids. Step 1. Identify the shape. Break the shape into simple geometric components. Rectangles, triangles, circles, etc. whose centroids are known and can be easily calculated. Step 2. Determine the centroid of each component. The centroid of simple shapes can be found easily. Rectangle, the centroid is the center of the rectangle. For a circle, the centroid is at the center of the circle. Step 3. Use the centroid formulas, where AI is the area of each component, and XI and YI are the coordinates at the centroid of each component. Steps continued. Step 4. Sum of the area or volumes. Calculate the total area for 2D, since we will not be using 3D in this class, or volume by summing the areas or volumes of the individual shapes. Step 5. Calculate the centroid. Multiply the area/volume of each part by its centroid coordinates. Sum these values and divide by the total area or volume to get the centroid coordinates. Step 6. Interpret the results. Example on how to find centroid. Find the centroid of the L-shaped area shown. Use the reference origin shown. Step 1. Divide the L shape into two rectangles. Rectangle 1, the vertical rectangle with dimensions 2 inches wide and 8 inches tall. Rectangle 2, the horizontal rectangle with dimensions 6 inches wide and 2 inches tall. Step 2. Calculate the centroid of each rectangle. To do this, you would take 2, for x1 you take 2 divided by 2, which is just half of the width, and you get 1 inch. And then for y1, you take 8 divided by 2, which is half of the height, and get 4 inches. So you have x1, y1 equals 1 inch and 4 inches. For rectangle 2, you do x2 equals 6 divided by 2, which is, again, half the width, gives you 3 inches. And for y2, you do 2 divided by 2, and it gives you 1 inch. So for x2 and y2, you have 3 inches and 1 inch. After that, step 3 is calculate the area of the rectangle. For rectangle 1, it's just 2 inches by 8 inches, which gives you 16 inches squared. Rectangle 2, it's 6 inches times 2 inches, which gives you 12 inches squared. Step 4, Use the centroid formula for composite areas, which gives you, for x, you do 16 times 1 plus 12 times 3 divided by 16 plus 12, which would eventually give you 52 divided by 28, which gives you 1.8 inches. And for y, you do 16 times 4 plus 12 times 1 over 16 plus 2, which would give you 76 over 28, which would give you 2.71 inches. So the centroid location of this shape is at 1.86 inch, 2.71 inch from the reference point. Thank you.